This video will showcase some of the primary tools available on Geographic Imager. I'll be demonstrating how to use the import, transform, crop, shaded relief, and mosaic tools to create a hill-shaded satellite image. In this section, we're going to go over how to use the Advanced Import feature in Geographic Imager. To access the Advanced Import feature, go to Files, Import, GI, Advanced Import. From the Advanced Import menu, you can use the Auto Detect Format option if you wish to view all supported image source formats at once, or you can select the format of the image source that you wish to import through the drop-down menu, which will narrow down what you can see in the file browser. As you can see, there is a large variety of formats to choose from. Click on the Add Image Source button to select which images to import. For this demo, we will be importing 3 TIFF images: the T19 TCN color, T19 TDN color, and the DEM. Once we have selected the images that we want to import, click Open to bring them into the Advanced Import menu. Once imported, you'll be able to see the file name, coordinate system, DEM schema, image dimensions, and color mode of the images, as well as the remove background color setting. These columns will update automatically if you make any edits to the image, which you can do through the Edit Image Source dialog box by double-clicking on the image you want to edit. Note that the coordinate system for the DEM is different from the color images, and also has a DEM schema, which is automatically applied to any grayscale image. There is also the option to mosaic images, which I will be demonstrating later on. Make sure that this is unchecked and click OK to import, and each image will open up in a separate Photoshop document. In this next section, I'll be demonstrating how to transform and crop images using Geographic Imager. With the imported DEM open, we're going to open the GeoCrop tool from the Geographic Imager panel. There are multiple methods available that you can crop an image using the GeoCrop tool. You can crop by extents, crop by position, crop to another document's extents, crop by vector file extents, and crop to coordinate system envelope. You can also draw your own crop area in the preview image. We'll be using crop by vector file extents. Please note that this doesn't crop to the exact vector outline, but to the extents of the vector boundary. Click on the crop by vector file extent icon and browse to the vector boundary shapefile to select and click Open. Notice that the preview image has changed to the cropped area, and the dimensions and raw size at the bottom have also changed. Click OK to run the tool. And you can see now that the DEM has been cropped. Now we're going to transform our cropped DEM to match the coordinate system of our other images. Open the Transform tool from the Geographic Imager panel and click on WGS84 to open the Specify Destination Coordinate System dialog. From this window, you can browse for a coordinate system by type, geodetic or projected, and by region. Or to find things more easily, you can use the search bar at the bottom. Since we already have images imported with the coordinate system that we want, we can close this window and instead under Destination, click Same As to set the destination coordinate system to WGS84 UTM Zone 19. And in the pop-up, select Keep the current pixel size. Normally, we'd probably choose Match the pixel size since we'll be mosaicing the DEM onto the images, but for the sake of time, we'll be skipping this. Click Transform to run the tool. You can see that the transformed image has transparent areas around the edge because we cropped the image before transforming it. The boundary vector file was originally in WGS84 UTM zone 19, but we cropped the DEM while it's still in WGS84. To fix this, we're going to quickly crop the image again using the GeoCrop tool, just like we did before, to get the proper result. Normally, it would be better to transform the image first and then crop it, but to cut down on processing times for the demo, we did it this way. You can see now that we've eliminated all transparent areas around the image. In this section, I'm going to demonstrate how to create a shaded relief layer using the Terrain Shader tool in Geographic Imager. With the cropped and transformed DEM we created in the previous section, open the Terrain Shader tool from the Geographic Imager panel. While we won't be using this in this demo, I do want to highlight the various options available if colorization schema is selected. Through the Methods option, you can choose to stretch the gradient to the DEM schema or use a preset color ramp. You can also choose to import a color map or export the current color map. The Use Continuous Color option smooths the color gradient, while Use Discrete Colors classifies pixels to specified colors only, and allows you to specify whether the color stop values should be treated as the minimum or maximum value of each class. Clicking on the pencil icon will open the Edit Color Map dialog box, where you can edit color stops in the gradient, map elevation values to colors, and set the elevation range. We won't be using a color schema, so we're going to uncheck it and make sure that Apply Shaded Relief is checked. The angle setting determines the lighting angle at which the elevation is rendered. You can input the angle directly in the text box or use the dial to set the angle. Any changes you make will be immediately visible in the preview image. We're going to go with 45 degrees, which is a pretty commonly used lighting angle. The intensity setting determines how hard or soft you want the lighting effect to be. Like the angle setting, you can input the intensity directly into the text box or use the slider. You can see that any changes you make are visible in the preview image, just like the angle setting. Use a lower intensity value for a softer looking shaded relief. Higher values create sharper looking shaded relief with more shadows and contrast. You can use any value from 0 to 100 as an intensity value. We're going to go with an intensity of 20. Click OK to run the tool. You can see here in the Layers panel that the Terrain Shader has created a shaded relief layer with an overlay blend mode. We no longer need the original DEM layer anymore, so we can go ahead and delete it. In this section, I'll be going over how to mosaic images together using the Mosaic tool. We're going to switch to the T19 CN color image and take a look at the Channels panel. Note that while there is a true color RGB image, the infrared imagery band is also present as an alpha channel. We're going to open the Mosaic tool from the Geographic Imager panel and move the T19 TDN color image from the list of available documents to the list of Mosaic documents. Next, we're going to make sure that the Mosaic alpha channels is checked. This will ensure that the infrared bands in both images are merged. In the Layer Options dropdown, we're going to choose Merge Source Document Layers and check Place Mosaic Layers above Destination Layer and click OK to run the tool. Finally, we're ready to mosaic our shaded relief onto the imagery. Open the Mosaic tool again and move the DEM to the Mosaic Documents list. Next, set the layer blending mode to overlay and leave the layer options the same as before and click OK. If we toggle the DEM layer in the Layers panel, we can see the shaded relief effect. Now that we're done, we can right-click and flatten the image and see our finished product.